Hello everyone, today we are going to see class 10 exercise 1.2 question number 1. So prove that root 5 is an irrational number. Okay, so we have to prove that root 5 is an irrational number. Okay, so first we are going to assume that root 5 is a rational number. Okay, so if it is a rational number, it will be in the form of p by q, right, where p by q are co-primes. So here instead of p and q, I am taking here a and b. So here a and b are co-primes. Co-primes are nothing but the numbers which has the only common factor as 1. Okay, if I take the numbers 17 and 23, the common factor between 17 and 23 will be 1. So I can say that these two prime numbers are co-primes because it has only 1 as its common factor. Both these numbers goes only in one table, right? So this is a co-primes. So I'm going to assume that it is a rational number which is equal to a by b, where a and b are co-primes and b must not be equal to 0. So we already know, right, where q must not be equal to 0. So here instead of q, I'm just writing b must not be equal to 0, because when the denominator becomes 0, we can't move further, right? So it must not be equal to 0. Okay, so and my next step is squaring on both sides. So if I square it on both sides, this root and square will be getting cancelled out. So this will be getting cancelled. So here 5 and the square goes to a and b. So I'll be getting a square b square. So I'm going to shift this b square to LHS side. So I'll be getting 5b square is equal to a square. So I'm going to take this as my first equation. So 5b square is equal to a square. Next I'm going to shift this 5 to RHS side by using the first equation itself. Okay, so if I shift, I'll be getting b square is equal to a square by 5. So here we can see that 5 divides a square, right? For example, instead of a, if I write 10 by 5, we'll be saying that 5 divides 10. So your answer will be 2, right? So same. So instead of 10, we are taking here a square. So 5 divides a square and also 5 divides a, right? It also divides its square and also the term a. So I'm assuming this is as my second equation. Now I'm going to assign a value to a, where a is equal to 5c. So since they have given root 5, so I'm taking here the same 5, okay, as my coefficient. So 5c. Okay, this is my third equation. So instead of and I'm going to substitute this third equation in first one. So instead of a, I'm going to just substitute 5c. So if I substitute 5c, so which is 5b square is equal to a square instead of a, so 5c square is nothing but 25c square, right? And here I have 5b square, so it's nothing but division. Here 1s are and here 5s are. So b square is equal to 5c square. Okay, so this is another value here, and with this equation I'm going to shift this 5 to LHS side. If I shift it, I'll be getting c square is equal to b square by 5, where 5 divides b square and b. Same here. So we have said that 5 divides a square and a. Same, we have to prove that 5 divides b square and b. So that I am assuming a value and substituting, so that I can get that 5 divides b square and 5 divides b. So I'm going to assume this as my fourth equation. From 2 and 4, we can say that 5 divides both a and b, right? Here 5 divides a and 5 divides b. So 5 is a number which divides both a and b. I am writing here from equation 2 and 4. So but this is a contradiction to our assumption. So contradiction is nothing but opposite to our assumption. So we assumed that it is a rational number where a and b are co-primes. Co-primes, as I said you, it has a common factor as 1, right? So its common factor is 1. But here a and b has a common factor 5 also, right? So it is a contradiction. It is a false assumption. Our assumption is wrong. So since our assumption is wrong, we will be concluding that root 5 is an irrational number. Okay? Why? Because 5 divides both a and b. So first we assume that A and B are co-primes, which has only one as its common factor. But when we proceeded all these steps, we came to conclusion that 5 divides both A and B. So this is a contradiction. So root 5 is an irrational number, hence proved. Okay, so not only root 5, if it is given root 2 or root 3, instead of 5, just you have to substitute the value 3, root 3. Okay, so same procedure for all the irrational number like root 3, root 7, root 13, all these. Okay, so that's it. Thank you.